Welcome back. It's time for another repair video. I know it's been a while. I've got something new for me to repair here, something I've never worked on before. So hopefully this will be interesting. So you'll get to see the unboxing. It's not going to be a long drawn out unboxing. I would not subject you to that. But here it is. Let's see what we have. A Nintendo Switch. A non-working Nintendo Switch. Now this is supposed to be complete with everything in it. Joy-Cons, the dock, and all of that other stuff is supposed to be new. This was supposed to be returned to a store somewhere, and just the main handheld unit was damaged or not working, so they swapped out just that part. One reason why I bought this particular one, because at least hopefully the accessories are known good, and that's something that I don't have to worry about. So let's take a look and see what we're getting here. Oops, I think I'm upside down. Yep, upside down. Try it this way. Let's see what we have. All right. Well, I've had a look inside this charge port. The other way. And I don't see any bent pins. So let's see what it does when we plug up the power adapter. See if there's any signs of life. And hit the power button. Where is it? There it is. Nope, nothing. I have ordered a USB current meter to go in line. It has not come in yet. So, well, I guess we have to take it apart then. I don't see any signs of charging or signs of life, which is as described. Let me look down at these screws. I'm trying to see how. Yeah, that's chewed up. That looks like somebody did not have a tri-wing and decided to take a Phillips to it. That's what that looks like. And what do we see? Well, I don't see liquid damage. That's good. I don't see any torn cables. Nothing obvious. I could check this battery voltage, I suppose. Very, very tiny contacts. You find my sharp probes. Where did I put those sharp probes? Here they are. Just curious if this battery is totally depleted. 2.45. She's not totally depleted, but 3.7 volt battery. That's below what it can operate at, I would imagine, but she's not dead, as in 0 volts. So that's promising. Now what I might do, since I don't have my USB ammeter yet, I've got to get that thing in here. I wouldn't mind hooking the charger back in and just seeing if this DC voltage changes any when the charger's plugged into it. You know, if it does anything. So we were 2.45, I think. What are we now? And we are the same, 2.45. A whole lot of nothing going on there. And let me rotate this plug around. 2.45. So no, we're not charging. I'd like to. I'm sure there's 5 volts somewhere here. I don't really know where. I wonder if it's right across this large capacitor right here. I would imagine this shield is ground, or right here on this screw on the USB connector. Wake up. Turn the light back on the meter. Hope that's in the shot. Oh, it is. Okay. Yeah, shouldn't there be 5 volts coming in here somewhere? I gotta get some light over here. Hope that's not in the shot too bad. My overhead light. But one of these should be 5 volts. I say that. USB-C, I think it can shift the voltage around as needed, but I'm getting nothing. Although, admittedly, I don't know where to probe. I want to say there's a fuse here somewhere. Is that the fuse? It says FL1 beside it there. Maybe that's not a capacitor. Maybe that's I've seen videos. I know that there is a fuse here somewhere. So let me unplug this power. Let's just see. We'll take a quick measurement, continuity measurement. Oops. Continuity measurement, quick light. Well, if that's a fuse, it's not a good fuse. Let me see. I've got to see. Back to watch some more videos to see if it's a fuse or not. I can't remember. It's in that general area, but that looks like a capacitor. Okay, I can confirm that what I was probing is not the fuse. That is a capacitor of some type, looks like. The fuse is, in fact, let's see if this is in the shot, right here. And it is tiny. I'm still in continuity mode. And that fuse appears to be, no, it's not blown. It's good. Yeah, we're good. Fuse is good. So that's where my 5 volts should be, or whatever voltage this adapter is putting out. Let's just see if we have anything there. Nothing. Absolutely nothing. I would think there'd be something, but I'm not real sure. I know with this USB-C there's some negotiation going on between, I think this is, one of these is the power management IC. Can't recall if it's this one or this one. Where it negotiates with the charger. Yes, I'm ready to send me voltage, but I would think there'd be something to begin with. But I'm still learning on this stuff. So, yeah, I don't know if there should be 5 volts there all the time. The things we need to know. Alright, I finally got a memory card in this microscope so I can capture some video. This IC right here is the power management IC. Handles the charging. You can see where there's the charge port right there. There is the fuse right there, which seems to be good. Get across it. It's good. Some kind of a little bypass capacitor here, which does not seem to be shorted. But yeah, right here's this IC, and I was checking some capacitors around it. You see some little, look like little tiny bypass capacitors right up here. Nothing there. But here, across this one, well, if I can get across one of them only, that one I'm getting 1.29 ohms here. You know, pretty much open. Actually, I get 11 ohms on that one. So I don't think that's normal. I have a feeling this IC is bad. It is available, luckily. I don't think they're terribly expensive, maybe $10. So I've got to see about getting one of those and getting some Kapton tape, and it's going to require hot air to get that out of there. It does have a large heat sink right underneath the center of it. I've watched videos, people replacing them. It doesn't look to be too bad, but I'm not terribly proficient with my hot air station. So I'm probably going to be doing a little bit of practicing. I've got to order this part and some Kapton tape. I could pull out this whole board, but there's a whole lot of tiny ribbon cables connecting these things together, and I don't like my odds on not tearing one of those. I think I could do it, but I'd rather not. I'd rather not test it if I don't have to. But this plastic, if you look, here's the battery right over here. That's the compartment that's the wall that contains the battery. Here's the battery right over here. So I don't want to melt this. I'll have to put lots of Kapton tape around there, all the way around, and there's a lot of tiny components that are going to try to blow everywhere. So I think it's doable. I've never done it before. So anyway, we'll learn as we go here. But I'm going to do some practicing on an old motherboard because I really don't want to mess this up. I think this thing is very repairable. The battery seems to be not totally dead. There's no water damage. So this is like, you know, for my first switch, this is a good win. I think it's repairable. So let me see if I can order this IC, the Kapton tape, and do some practicing. And through the miracle of editing, it'll look like it happens really quick, but it's probably going to take me a week to get this part in. Well, it's been about a week and a half waiting on parts to come in, and everything has finally arrived. Got my Kapton tape. I've got some liquid flux, no clean flux, and I've got some Goot wick for cleaning up some pads. And I've got the IC, which I want to show you now. Been waiting like a week and a half for this, and there it is. Now, do you notice anything about this IC? This IC that is supposed to be brand new, that has solder on every pad. Yeah, it's not brand new. So I've already contacted the eBay seller. I don't know what's going to come of that. I'm hoping this is at least a working pull. Because if I put it in there and the device doesn't work, then I'm going to be kind of going, well, was it the chip or was it just something else? Anyway, so it's not what I was hoping for. This took so long to get that I actually ordered another one from a place in Florida, I think it was. So that one, if all else fails, maybe that one will be new. But this one was supposed to be brand new, is what it said on the listing. So anyway, I've got some taping off to do with some Kapton tape, maybe a little aluminum foil here and there, and we'll see if we can get this thing put in there, and hopefully this will make a difference. Oh, you might notice up here, right there, capacitor is gone. Yeah, I got a little impatient. That's the capacitor that was reading like 1 ohm to ground. And I got impatient waiting for the chip to get here and got to thinking, what if it's just the capacitor? You know, what if it's just it's a 1 microfarad capacitor? What if it's shorted and that's all the problem is? And it was not shorted. I took it out and I got to do some cleaning up in there. But I took it out. It does measure 1 microfarad. All 3 of these I think are going to be 1 microfarad, all identical. Here, here, and here. And so there was nothing wrong with it though. But anyway, I did take it out, and as I put this in, I'll have to also reinstall that capacitor. But so let me try to get started. Well, I tried for a long time to remove this IC under the microscope, and it's just not happening. I don't know if I'm not using enough heat. I think I just can't get the angle right because I don't have a bent nozzle, so I'm having to coming in at an angle every time I approach the thing. So I'm going to try doing it out from under the microscope, see if a better work angle will make the difference. It's finally off, and here you see a picture of the aftermath. That took a lot more heat for a lot longer than I really thought it should. It took a lot of heat before it would even begin to move. I'm guessing that's, lead-free solder does that sometimes, but nothing damaged, although I have moved some components, and I may have lost a resistor. This capacitor here was floating around. I think it should go back right over here. And I see a resistor I moved here, it goes back here. This resistor link sits back to here, and that one we have to find. I'm hoping it just kind of blew up under my Captain tape up here, up under there. But this is the one I took off earlier. I was going to stick it back down when I was putting things back. I see a capacitor down here. I've moved a little. I need to back my air down, I guess, but I was playing with different temperatures, different airs, just trying to find some combination that would make this thing move, and it was not easy. I'm sure that heatsink pad had something to do with it. But it is off, and I don't think I've heard anything yet. And hopefully it'll go back on easier because I'm gonna wick away this lead-free solder as best I can and replace it with some leaded solder. So hopefully that will melt a lot quicker and we'll go down, and hopefully this will all go back together easier than it came off. Well, ladies and gentlemen, we are at the moment of truth. It's been about 3 weeks since I started working on this thing and took that chip off. I've been waiting on parts to come in, and of course I lost some parts, or at least I thought I did. When I took it off, I slid it to the side and took off a couple of resistors and capacitors, so I had to wait for those to come in. I did find them on the IC, but the capacitor ended up losing its end cap while I was taking it off. A little too much heat, been heated up too many times, I guess, but anyway. So I had to wait and get a new capacitor, several resistors, in the tiny 0201 package, which is a speck of dust. So in that time, though, I did get my USB ammeter in. I don't have anything to compare it to as far as the way it was taking current before, but I do know what it should be taking just by watching some other YouTube videos. I think normal is like 460 mils, something like that. So at least we have something to go by here. I hope that's showing up good on camera. I'm going to, well, I'll turn that light off and maybe the glare will go away. I'm going to reconnect this battery terminal, which has been unhooked this entire time. Alright, I'll turn this light off. Now, let's see what happens when we put some power on this thing. That doesn't look encouraging. 0 amps. Absolutely nothing. Turn it over. And 0 amps. Okay. Now what? She's not charging. I have not tried to turn it on, but she should be trying to charge at this point. Where's that power button? And there it is. Oh, the backlight came on. I saw the backlight come on for a moment. Just for a moment, I could see it glowing. Oh, there she come up. But she's not charging, which I think is going to be a problem. An error has occurred. 2134-0501. Okay, never seen this, but it wouldn't come on at all before. She's definitely not drawing any current off this USB adapter. So she's running off the battery. I did try to charge the battery a little bit. Disconnected. I actually made some little terminals to go into the battery, and I applied, 4 volts. I can't remember. So I did put some charge in the battery manually. At least I thought I would. An error has occurred. Press the power button to restart the console. Okay, let's see what happens. It went right off. Oh, right back on. Okay, not sure what it's doing now. Maybe that was the shut-off sequence. Nope, we're back up to an error has occurred. Well, okay, let's see if I can give you an update. This cord out of the way. A lot of you may have noticed, if I showed you close-ups, the soldering on the chip I thought was good, but got to looking at it closer, and obviously there was dry joints, and there was dry joints all the way around it. So I went around with a pencil, soldering iron, touched up the questionable looking ones, hooked it back up, or turned it back on, and it booted completely. Went past the switch logo screen and came up and ran. And I was excited, and it worked. Wi-Fi worked, but it still wouldn't charge. Still no charge. So the battery was at like 30%. So I just played with it a little bit and just kept looking at those joints and looked around, found even more dry joints. So touched those up. I was looking at them real close under the microscope, touched those up, and suddenly we have a working switch that is charging at 38% at the moment. So I was very excited at that point. I think I'm finally through with this one. Yeah, I know I've got some work to do on my soldering on the hot air side of things there, but this stuff is tiny now. This is some tiny components. I call them grains of sand. I've had to replace some of these. A lot of my problems are because I wiped some components off accidentally, pulling that chip off, which maybe if I'd had my heat and air a little bit better, I wouldn't have slid the chip to the side. We know when it came off. So anyway, I'm learning. So that's where we are. It's working. You can see the fan running at the moment. I don't know if you can tell. And hopefully I've learned something. Hopefully I've gotten a little bit better, because we have another one to fix. Came in the mail a couple days ago. I have not even bothered opening it yet. Only one at a time. And but it looks like I have a working one now, and hopefully I'll have working accessories to go with it, like the dock that I have that came with this one, and the Joy-Cons are all brand new, still with the plastic around them. So I'll have known good parts to test this other one with. I probably could have, something I could have done. I did not have another battery. I have a feeling if I'd had another battery to swap on here, it would have come up before. It would not have charged, but it probably would have come on and powered on and given me a screen. But the battery was totally discharged. I'm guessing whoever had this thing before, it wouldn't charge. They just used it till it would not run anymore. The battery was depleted, and I had charged it some with the bench power supply. I had set it on like 4 volts and a constant current of like 460 milliamps, because that's what I had seen it charge on the USB power meters on other people's YouTube videos, like 460. So I let it run like that for, I don't know, an hour, charging the battery. So that's why there was some charge on the battery when I first tested it after replacing the IC. It powered on, and it would not come all the way up though, which was something interesting. It would not come all the way up past the, it would just give that error message because of joints. I'm guessing the processor could not communicate to this chip properly, so it just hung right there. And a few more dry joints and she's back charging, and anyway, that's where we are. So it's worked. I hope you enjoyed this, because like I said, I've got another one coming. So, and that's it. Thanks you for watching, and if you enjoyed this, if you learned anything from it, I know I did. If you learned anything, give me a thumbs up. Thank you. Catch you in the next one.